Okay, hello everyone. My name is Naifan Zhuang, and today I'm going to do the project representation. And my project is face detection and recognition based on PCA and getter filters. So let's move on. Okay, this slide just shows the problem goals I'm going to do with my project. The first one is I want to gain the ability to recognize a face and crop out the appropriate image. The second, I want to gain the ability to recognize faces whom the face belongs to. And third, and the last one, I want to determine whether or not a person's eyes open, closed. Okay, so this slide just shows the directory of today's presentation, and you can see the first one is face detection, and then face recognition with PCA. Third, with getter filters, and the last one is I want to analysis of eye detection. So the first one just go of face detection. Okay, so I want to determine there is a face in the image input from the camera, and also if it exists, then mark and crop the face cam area. And at last, all this process will then be implemented with MATLAB. Okay, let's see small incident, just ignore it. So this is the result of the face detection. After running the algorithm, we got the results. You can see from source image, binary image, face marked image. You can pinpoint the face. Also, in the end, you can get the cropped image. Let's just see a program running. So, sorry. This is code for the face detection I wrote, and also I will not go through all the codes. So let's just run the codes. Okay. So we just get the main screen of the program, and so now you can just capture it. Okay, I just capture my picture, and when I just get close, okay, I just get the picture myself. So on the screen on the right side, just the binary image of myself. So let's get back to the presentation. You see, this guy okay. So this is a face detection, and the results we can see. Okay, this picture is just a controlled background. I mean, for the face detection, skin color model and eye extraction is not the most efficient way. However, it can still be used, and the background is simple and robust. So let's move on to the recognition with VCA. These are the 4 pictures I want to show today. I do 4 groups of increments. Okay, let's see the left side. Picture A, picture C. We can see we got the same person. I mean the correct person found. But in the picture right side, it seems we get the wrong person. See, the different persons. Okay, so and I have said before, just compare the correctness of the picture of the recognition result. So we can get wrong sometimes with probability about 10%, and show the in picture B and E. You see another incident. So therefore, we can safely draw the conclusion that the PCA algorithm is not perfect, and we also implemented other ways to do the face recognition. So in the third part, we do the face recognition with getter filters. This is just the result. The 2 main algorithms we used were the Fisher linear discriminant analysis and principal component analysis. The figure is a result of a simple picture after being convolved with a series of Gabor filters. The first part, I just want to do the fact eye detection. You see the closed eye state, open eye state. And also, you can get different MATLAB plots. See in MATLAB. So after coming to the conclusion that real-time eye state detection will not work, we decided to see if PCA and LDA will have a large difference in classification like they did for face recognition. I used the data we gathered from the real-time detection and classified it using the same algorithm that were used for face recognition. The classification used LDA was far better than the classification used PCA, beating it to from 96% to 78%. So I became very curious as why LDA performed so much better than PCA in our project. Okay, I looked at some papers. Some papers shows that LDA is not necessarily better than PCA, and it's fully dependent on what was used for feature and classification. And also algorithm combine LDA and PCA are much better than using each one of yourself. So other papers claim that, yeah, you see, it's another. Oh, sorry. See, different opinion. Just other papers claim that a well-established fact that LDA classifies better than PCA. So now, for myself, I'm of the opinion that the size and the type of application determines which is better. LDA may be better for pictures that are more static in nature. For instance, the people in the images will always be looking forward, their eyes open, no facial expressions. However, PCA is a more robust algorithm and can take into account of the variations like those just mentioned. Mention the word. Just will look whether your eyes open or not, and whether you have facial expressions. So, apart from those we've talked about, do not wait to show to me. Okay, apart from those we've talked about, the size of databases may also have a large effect on the classification rate. My database only has images from 40 people. Okay, so if the application spans the entire city or state, my result may, scale much differently. So that's just about recent work, pattern recognition, specifically in facial recognition. So in 2006, we just gained the FRG, and then new algorithm just doing the face recognition better and better. You see just the difference between 95 and 02. Okay, since 1993, the error rate of automatic facial recognition system has decreased by a factor of 270. And most laws show that error rate decreased by 1/2 every 2 years. I believe that further improvements in higher resolutions will just resolve the issue of insufficient resolution. So I also want to thank Professor Wu for his detailed and thoughtful teaching and his sincere and careful tutoring. He carefully replied each of the emails which asked questions about the project, and other students, all can share answers and advice. They are very helpful to the project because at first I barely knew where to start. So after finishing the project, I benefit a lot. I gained knowledge and experience of pattern recognition. So thank you, and thank you for watching my presentation.